today's video I will be discuss about the types of LVDT. So here we driving into topics like types of LVDT, advantage, disadvantage and application. We also touch on AC LVDT, DC LVDT plus when you move the armature of AC LVDT we can classify it based on that too. So let's break down the types of armature. We'll look unguided armature, captive armature and spring extended armature in LVDT. First up, let's check out this type based on that. Let's look at the armature type. First off, it doesn't have any specific guidelines, meaning there are no restriction on where it can be used. Check it out. The armature is marked armature is marked in black here and it moves freely inside. The arm we have here is usually where we attach the object. So for the arm we will attach it separately and make sure it's properly aligned, because if it's not aligned we could run into alignment issue. From this point, this one is going to be unguided armature. Okay, so this part here is totally parallel and armature is completely disconnected from the LVDT body every meter. There is no contact in between. So another great things is that here won't be anything bare, because the mechanical setup of the LVDT keeps it practically infinite. As long as there is no friction, its mechanical life can last identified. Plus, its resolution can also be infinite, because we can move it however we want. That is the armature. The unguided armature type next to the captive armature type is pretty much the same as unguided armature. Unguided armature. Okay, here you can see that the bearing assembly is connected and inside there are small metal balls that support armature. That is it. Okay, so this setup provides support, and aside from that we just have a major object. Overall, this is a low friction assembly, meaning the bearing assembly is attached here. This type of armature is usually used for long distance measurement, as we know with LVDT and laser beam transmission LBT. Okay, for displacement measurement we use a range from plus or minus 0.5 to plus or minus 18.5 inches. So now looking at the bearing system, next we have a spring extended armature difference. So you can see here also, you can hear also bearing ball here, and in addition you can, there is a spring provide for maximum extension. We can use it until we reach that maximum extension. The difference is that previously we had unguided type, meaning the armature and the body were part of that. We cannot separate this in this case. This type of LVDT is called the captive gas spring return type, which has a spring extended armature, and the contact with the target surface is for measuring the surface displacement, and the surface displacement will remain the same as the spring cut displacement. Okay, so we can also use it for the surface measurement. So that's the deal with the spring extended armature type LVDT. Now regarding the availability based on output power, let's break down the AC LVDT and DC LVDT. So in case of AC LVDT, first up, this is the AC LVDT, which has one input and one output. The cool thing about this, it has great resistance to shock and vibration. Plus, it can handle high temperature ranging from 200 degrees Celsius to 500 degrees Celsius. It can also work with electronics located remotely, so we can use it with outdoor electronic circuit. However, this LVDT tends to be cheaper and it requires an external circuit for signaling conditioning. Here the deal, if I need to connect an output here, I have to hook up this lead wire to a signal conditioner. That's this lead wire to the signal conditioner. That because in an LVDT there are some output signals that are kind of tricky, similar to the DC LVDT, where you have a power input but the output is DC. You can see that signal conditioning equipment is set up on the LVDT. Basically it all looks the same as this LVDT. So but the output is going to electronic circuit for signal conditioning. Okay, now you are gonna do the DC conversion. If it is not if it's got retirement, it can also be converted to digital. The temperature range decreases because we know electronic circuit have their temperature limit. That is why the overall temperature range gets lower. So the built-in electronics eliminator reduce the volume, weight and cost of external excitation equipment. So in this case there is no need for external excitation equipment. The digital output goes directly to the computer system, so we send the output to the computer. So you can definitely use local you can see LPG, and the biggest advantage is that it's more cost effective and works well in most environment. If set aside the temperature range issue, the overall cost is higher, but when we consider maintenance and everything else, there are clear advantage to using LVDT. It offers us efficient operation but is also sensitive, meaning even small changes in displacement will still show some changes in output. You can use an amplifier here, and the history of losses is usually lower because in the moving assembly there is no friction like in other types, or it stand because of the assembly. It means lower power consumption and it converts displacement directly into electrical signals, so we get the output pretty quickly, and those are the advantage of LVDT. Now let's talk about some disadvantage. First of all, there is an inductive issue. This type of transducer, which means it's sensitive to magnetic fields. Here the magnetic field spread out, so its affect the performance. That's a downside. The primary transducer will convert this quantity into displacement. Then using a secondary transducer like an LVDT transducer, we can turn this displacement into electrical voltage signal. Finally, the last application of this, it is used in the industry. So Well, today we are dividing into mechanism, industrial automation, aircraft terminology, satellites, and more. So that's all for today.